Welcome back to the Caribou Data Science Show. I'm going to continue my exploration of Benford's Law, cases and deaths. Uh, I'm basically doing the U.S. states by population. I'm not sure how many total states I'm going to do, but we'll see. So now we're moving on to North Carolina. Okay. North Carolina cases. Let's come back up here, run the initial data up here first. Okay. Let's look at North Carolina's cases now. Now, what is this? Let's call this North Carolina. What's the difference up here? Yeah, filter. Does this work? That works. So what's the difference up here then? It must be smelling. It must be spelling. Oh, I know what it is. I have to keep adding states back up here. Okay. So once again, cases fit pretty closely. Well, there seems to be there seems to be a consistent pattern, doesn't it? Cases fit Benford's law pretty good, all right, but deaths don't. Let's call. We're going to do this. Okay, we'll change all these. And from this point on down, we're going to change. Let's do this. Okay, good. Okay, so okay, let's do this now. So let's take a look at Michigan's cases. Okay, so once again, you can see this is 24 point for cases. Just to keep it consistent, let's just change this. So you can see, okay, now you can see this is still 24%. It should be like 31. Okay, let's come down here. Okay, where are we here? Michigan. What did deaths tell us? Well, deaths continue to tell us that deaths seem to be understated. I actually sent a an email. Actually, I sent an email to one of the person who actually is the primary author and maintainer of the Banford test or the Banford dot analysis library. And he said, well, let's just take a quick look at that email and see exactly what he did say to me. Okay, you know, it was really glad to see him actually reply to me. I was very kind of him. Okay, Carlos does. Let's see some of that for the test. Here we go. This needs to be approached with caution. You can sure use it as an exploratory tool, but not to prove. The first thing to keep in mind is, should we expect COVID-19 numbers to follow Bedford's law? Why not? Perhaps since it's a function of population size, we should, in some way, if we consider cities as a unit of analysis. However, since different cities also have different measures, perhaps not so unclear. Okay. My basic, I think my basic idea is if we say that New York is shaving their numbers, and that their death numbers, and therefore Brimford's law shows a particular trend of those numbers. Can we say that that's what it looks like? That's what Brimford's law looks like in the case of understated deaths. Okay, so here's the thing: we got Michigan here. Michigan cases looked okay. Deaths look a little low. All right. So next we'll go to go to Jersey. Some I like to call it Jersey. Let's take a look at. Let's just once again the cases look reasonable. Okay. These two. So this is New Jersey. Now, this is interesting. New Jersey's, well, it's still 0.25, 24.4%. Okay? Okay. Okay. Let's take a look at one more state for tonight. Oh, that's what they got a gap there. Let's take a look at Virginia's cases. Once again, Virginia's cases are, well, they're not perfect. They're 27.1%. Okay. Okay. Because they're applauding you. That's why. Well, maybe. And once again, we consistently see the deaths as being a greater separation between the deaths and the cases, comparing deaths and cases. So, what do we look at today? We've looked at uh, we've looked at North Carolina, Michigan, and New Jersey and Virginia. Okay. Thanks so much for your time. We'll catch you in a day or two with some more analysis.